Today we are going to discuss about the development of brain. Okay. Yesterday or in previous class we have studied that how the neural tube is going to form. Now we will take this neural tube separate along with the neural crest cells are here. Okay. So the cranial portion, this is a cranial. This is cranial side and this is a caudal side. Okay, in the cranial side, after the formation, above this development of somatomeres, okay, at that where this branchial arches are going to form, at that area of the neural tube is going to develop as a brain vesicles, and the development of brain vesicles, primary brain vesicles are going to form, and this is going to happen on the 5th week of the conception. And this is what the area where the anterior neuropore was closed. It is represented by lamina terminalis. Remember, the anterior pore closed and that area was represented. That area is going to represented by lamina terminalis. And there are three primary brain vesicles are there. Most cranial side, prosencephalon, forebrain, and the middle mesencephalon midbrain, and most caudal part it's a rhombencephalon, it's called as a hindbrain. Okay, and this forebrain is going to develop further into secondary brain vesicles are going to form. So what happens in the prosencephalon? The caudal part of this prosencephalon is not going to develop, they are not going to bulge up. But on either side of the prosencephalon, there are the lateral bulgings are going to take place, and that lateral bulging is called as a telencephalon or cerebellar vesicle. Okay, the one which does not bulge out, that portion is called as diencephalon. Okay, diencephalon. And also there is a small bulges of the optic bulb and thalamus part, small portion of the thalamus is going to develop in this diencephalon, right? All type of thalamus will comes under the diencephalon. We'll see what are the structures are going to form in the brain later. Okay, and the mesencephalon does not bulges out, and that will be remain same. And that is going to develop as a midbrain. But the thing is, the rhombencephalon. The rhombencephalon is going to bulges into two separate sections. The cranial part of the rhombencephalon bulges out, which is called as a metencephalon, and the caudal part of the rhombencephalon is going to bulges out, which is going to form as a myelencephalon, right? And not also this one. Okay, now we will see that this is a rhombencephalon part. Okay, rhombencephalon part. This is a metencephalon, and this is a myelencephalon. Okay, from the metencephalon, pons is going to form. And from the myelencephalon there is a medulla oblongata is going to form. Medulla oblongata. And not only with the pons, on the posterior aspect of the myelencephalon there is an elevation will come like this, and this is going to form as, and this elevation is going to form as a cerebellum. Cerebellum. Okay, this is cerebellum. So from the metencephalon, pons and cerebellum are going to form. From the myelencephalon, medulla oblongata is going to form, right? The structure derived from the telencephalon is nothing but the cerebrum, and the structure from the diencephalon are the optic bulb and the all type of thalamus, metathalamus, subthalamus, and hypothalamus. All thalamus are going to form by the diencephalon here. Okay, this is the area where it's going to form as a thalamus. Next, in the midbrain structures, superior and inferior colliculus are going to form in the midbrain, and their brachiums are going to form. And from the metencephalon, pons and cerebellum. Pons and cerebellum are going to form, and from the myelin cephalon, medulla oblongata is going to form in the adult brain. Cavity within the cerebrum, they are going to develop and called as lateral ventricles, and cavities of midbrain is called as a cerebral aqueduct, and the cavity of this hind brain is going to form as a fourth ventricle, and further the cavity in the spinal cord is going to form a central canal. Okay, and this is about very brief about development of brain and brain parts by the neural tube, cranial part of the neural tube. The development of spinal cord. Already we know that there is a neural tube is there. Neural tube having central canal. First, usually this neural tube was straight as a neural plate, and the surface layer of the neural plate is going to develop as a neuroepithelial cells. Later on, the neural plate is going to convert into the form of a tube after the joining of neural folds, so that the neural epithelium. So neuroepithelium cells will come inside the cavity of the neural tube. Okay. See, this is the neural epithelium. So neural epithelium is the stem cells which are going to produce a lot of structures inside. So what happens? These neuroepithelial cells which are going to proliferate mitotically, they are going to multiply and create multiple layers. Here the neuroepithelial cells are going to proliferate and forms three distinct layers. So most inside layer is a ependymal layer. Okay, this is the ependymal layer, and the second layer, the green color what you are seeing, is about the mantle layer, and the outside red color what you are seeing, that zone is a marginal layer zone. So three layer zone, ependymal layer inside, mantle layer in between, peripheral there is a marginal layer will be there. In spinal cord what happens? Usually in this layer, the neuroepithelial cells which going to while dividing mitotically, they produces many progenitor cells for the neurons and neuroglia cells. All those will get migrated from the ependymal cells towards the mantle layer. Okay, almost all cells will be. When there is no cells left, mitotic division in the neuroepithelial cells, then that inner layer is going to called as a ependymal layer. Okay, here almost all neuronal cells will come, and the neuronal cells, they have their cell bodies related here in this layer, and their axons are going to spread out outside towards the marginal layer. Okay, and in marginal layer, the neuroglia cells which present inside the mantle layer, slowly they are migrated towards the marginal layer, like the oligodendrocytes and astrocytes, which are going to come towards maximum towards the marginal layer, and they are going to form the myelination around the nerve fibers which present inside the marginal layer, nerve fibers which are going to extend towards the marginal layer, and they form the myelination around this one. So by this what we can understand, the mental layer which has a collection of cell bodies, neuronal cell bodies, is going to develop as a grey matter because cell bodies are there and non-myelinations, not much myelinations are there. And the marginal cell layer which will be having a neuroglia more abundantly, and they are going to myelinate, that's why they appear white, and this marginal layer is going to form a white matter. There is a sulcus limitans is going to appear in between this mantle layer. Due to the stretch of that sulcus limitans, the oval shaped cavity of the neural tube will become diamond shaped. Okay, and that is going to divide the developing neural tube into the quadrangular shape. here the ependymal cell layer here, this layer doesn't have a neurons here, and this part of the area is called as a roof plate, and below this one here the is called as floor plate. Okay, so here there is no neurons out there. Okay, on the dorsolateral side and ventrolateral side of this mental layer, the neurons are going to proliferate and increase their numbers, and they will have a dorsolateral elevation and ventrolateral elevation. Okay, the area of this dorsolateral elevation is called as a alar plate. Okay, the dorsolateral elevation of the mantle layer is called as a alar plate, and which is going to develop a sensory. It's going to develop a sensory part of gray horn of the spinal cord. This is a sensory nature. The neurons here in this alar plate are going to form a sensory part, and this is a basal plate. Okay, the basal plate of this ventrolateral elevation of a mantle layer is going to form a basal plate, and which is going to have a part of a motor neurons. They are having motor neurons. Okay, if you remember the face of a rabbit, it has ears. So ears, ala is ear, and it's a sensory in nature. So its alar plate is for the sensory, and you have foot. Okay, so the foot are there. These foot is representation of the movement, motor. So here the basal plate is going to develop as a motor neuron. Okay, so as this development of a basal plate and the motor plate, at that time even the marginal layer are going to develop in abundantly. They will also increase their thickness. As this basal plate is going to develop here, this is one basal plate here, and it is going to develop like short and thick portion on ventral side, and the alar plate long and thin side on the dorsolateral side. This is going to divide the marginal layer into three parts. So behind this one, this is called as a dorsal white column, and this much portion of the marginal layer is going to become a lateral part, and this much will become a ventral part. Because it's going to form a white part, it's called as a dorsal white column, and this is called as a lateral white column, and this is called as a ventral white column. And due to this development, the alar plate and the basal plate of the mantle layer will appear H shape. Okay, will appear H shape. As this development is going to take place, the large cavity which was there present previously will become very small and retain as a central canal of the spinal cord. And what are the cells which are covering inside the central canal? They are ependymal cells. Remember, ependymal cells. Ependymal cells are going to form the inner layer of the ventricles of and inner layer of the cavities of all part of the CNS. Okay, this is about the development of spinal cord. Many students will ask whether the oligodendrocytes present outside why they are not present outside the CNS, or why Schwann cells not present inside the CNS. They are not because the Schwann cells are the part and parcel of the neural crest cells, and the oligodendrocytes are developed inside the neural tube cells. They are not same. They are originally something different. That's why Schwann cells will not present in the CNS, and oligodendrocytes not present in the PNS. Okay. So one here is small concept we are going to discuss here. So we know that this is a dorsal root ganglia, right? In the dorsal root ganglia we have pseudounipolar cell, which pseudounipolar cell will have the central process and the peripheral process. This peripheral process will carry sensation towards the cell body here in the dorsal root ganglia, and the central process will carry sensation towards the CNS, and this is going to end up here. Okay, from here this is called as first order neuron. Okay, it's called as first order neuron, right? And from here the second order neuron, cell bodies of the sensory part of this grey matter, dorsal grey horn, and this carries sensation towards the CNS for the further relay. Okay, like this. Okay, and this is a second order neuron, right? So always remember, first order neuron are the part of the PNS. From second and third order neuron are the part and parcel of the CNS. Okay, this one you have to remember. So in next class we are going to discuss about the other part of the CNS.